Hey there, I got your follow-up question. So it looks like you're asking, what would have caused me to turn the 12 underneath the 55 to 2 times 2 times 3? And the answer is that's kind of the plan for reducing fractions. What we want to do first is factor, and then second we want to cancel. And well, if you end up having to take the next class after this, you'll see that also with algebraic fractions. They work the same way as these numerical ones. And so what factoring is writing something, if you can write it as a multiplication, um, that's factoring. So if I had this 10, I'm just going to do a little bit easier problem here for a second, and then we'll go down to something a little less pleasant. 10, the only two things that can be is 2 times 5. There's nothing else that multiplies to 10. And so 2 times 5 is what's called the prime factorization of 10. This is the most broken up I can make it in terms of something times something to make the 10. And 3 times 7 and 5. And then again, we're just canceling out factors of 1, so 5 over 5 would make 1, and then we can multiply straight across with what's left. So 2 times 7 would be 14, and 3 times, that's essentially a 1 now, would be 3. Another way of looking at these ones that are easier, and you may have seen this way in school, is where you kind of reduce within the fraction. So with the 3 and the 7, those are already prime numbers. Those can't reduce at all. But 5 and 10, 5 does go into 10. So I can think of this as 5 goes into 5 once, and 5 goes into 10 twice. And there's the exact same 2 times 7 for the 14, and 3 times 1 over 3. And that's a great way of looking at it when the numbers are pretty clean and easy to look at. Sometimes they can get a little bit trickier, so I'll do this one down here with kind of the extra steps. The other problem with doing this is it's easy to maybe miss, kind of like where you had before with the 20 over 6, I think was what you got on the first round of doing that. It's easy to miss something in there if you don't factor it down all the way. So let's look at one again that's a little bit more kind of like what you saw in the homework. I'm going to run through how to do the prime factorization of 120 and then try to convince you it isn't necessary. But kind of holding with our first step is to factor everything as much as we can, and our second step is to cancel all the factors of ones, and that will always get you the most reduced form with multiplication or division with fractions. So to do prime factorization, the version that I tend to do is the one that's kind of the tree, where we go, okay, think of any two numbers, doesn't matter what they are, that multiply to be 120. So to me, the easy one is 10 times 12. That's the one that pops out. But I could have also picked 2 times 60 or 3 times 40. Any two numbers that multiply to be 120 would have worked. And then I look at each of these numbers and go, can I break them down further? So with 10, yeah, so 10 can be broken down to 2 times 5. So this branch of it, that's as broken down as I can get, because 2 and 5 are both prime. In other words, the only things that multiply to be 2 are 1 and 2. The only thing that's multiplied to be 5 is 1 and 5. So that makes those prime numbers. For the 12, though, I can think of, is there any two numbers that multiply to be 12? Sure. This time I'll go 2 times 6. I could also go 4 times 3 like I did in the last video. And I did the 4 the last time because it was convenient with the 4 that was also in the problem. But either one of those would work. And then the 2 is prime, so I'm done on that branch. But for the 6, I can go one more step and get 2 times 3. So what that means is the prime factorization of 120 would be, let's see, 2 times 2, I'm going to put them in order, times 2 times 3 and times 5. So if you multiply all that out, 2 times 2 times 2 would be 8 times 15 does make 120. So this is the smallest I can break 120 down to. So this is what they would have shown in the written example. And I'll go ahead and do this way. And then I'll try to convince you to do it the little bit easier way that I'll show you in just a second. So there's the 120 all broken out into its prime factors. That's going to have a 7 up there, so I'll write that in. 21, that is a 3 times 7. And then 12, like we just found here, is 2 times 2 times 3. I guess I could have written that in order, but I didn't, so it will all be fine. Oops. At least get the 2's in order. Okay, so there's the prime factorization of 120, so that's broken down as much as I can, times a 7. 21, there's our 3 and 7. 12, 2 times 2 times 3. So that gets me to the step now where I just look for factors that are the same so I can cross them out because they would just be 1. So 2 over 2 would make a 1. 2 over 2 right there makes a 1. I can get rid of the 3 and a 3. Nothing special about that one. I could have marked out that one too, but just one of them because 3 over 3 makes 1. And then we got 7 and 7 right there. And so it looks like what is left is a 2 and a 5 up top, so that would be a 10, and downstairs just 3, so that should come out 10/3. So that's kind of the way the written example would do it, where it breaks it down like as far as you can possibly go. So that's probably not what I would actually do though. If I was going to do this problem for myself, if I can spot that 12 goes into 120 10 times, I can do a lot less writing. So let me show you what I would do there. And this is the same as I did with that 4 in the last example that I did. I would think of that 120 as a 10 times 12, and that's not fully factored, but it doesn't really need to be if we can see what we're going to cancel. Downstairs 21, I'm going to make that I'm not going to make that a 3 because 3 doesn't, oh yeah, I am, sorry. 3 times 7, I was thinking of a different number, my bad. And then right here we have 7, and right here we have the 12. So in this case, I'm not bothering to break down these 12s because I can see I can cancel them. It's like I did earlier where I can go 12 goes into 12 once, 12 goes into 120 10 times. That's exactly what I'm going to do there, and I'm going to cancel out those 12s, leaving the 10. So it's a nice little shortcut, and it saves you a bit of work if you can spot kind of the greatest number that goes into both of them. But if not, doing it the long way works well as well. I can knock out those 7s, and boom, we're right back at the exact same 10/3. So the goal is just to basically get it where you can see what cancels. Again, kind of the danger on this one is, here, let me actually go back and do that wrong for a second. And let's say we noticed, grab the eraser there. Here's the little bit of danger for this. Let's say for whatever reason, instead of 12 going in, let's say we happen to notice 6 going in. So 6 goes into 12 twice. 6 goes into 120 20 times. And then we crossed out the 7, and we said 7 goes into 21 3 times. That's where, you can see I did everything. All that was legit math. But this 20 and this 2 would still reduce down to that same 10 I got there. So that's kind of the issue with doing this with the bigger numbers, is it's kind of easy to miss one of the factors. If you do it out all the way, you won't miss a factor. As long as you do your prime factorizations right, it's going to come out right and fully reduced every time. This is kind of the halfway in between these two, where I'm like, I don't want to write out all that. Can I shortcut this a little bit? And if I can spot that 12 going into 12 or 120 10 times, then I can kind of again shortcut some of the writing. The other thing I like about writing it out this way instead of this way is if you had 20 over 2 there, it's a little more obvious that it's there, then maybe my handwriting gets bad when I do the cross-out method. Anyhow, those are all the same thing. They're all factoring and canceling, but that's kind of the deal, is you want to factor first and then cancel. And if you can cheat factor a little and spot the biggest one, go ahead and do that. It'll just make it a little bit easier. Hopefully that answered up your questions. If not, feel free to post again, or I'm sitting here in office hours right now. You're welcome to drop in.